Hello, I'm going to demonstrate how to perform oral emittance measurements and how to analyze and interpret the oral emittance measurement findings. Let me look in your ear first. Okay, I can see your eardrum. Okay, good. Before we start a test, I have some questions. Have you had any ear surgery before?
No.
Good. Do you have ringing in your ears?
No.
Good. And do you have any ear pain?
No.
Okay, good. The first test I'm going to do is checking how well your eardrum is working. I'm going to insert this soft rubber probe tip into your ear canal, and you will hear some buzzing sound. Then you will feel slight pressure changes in your ear, like going up in an elevator. And then you will hear some loud sounds, but it will last only for a second. And you don't need to tell me that you hear the sound. So please remain still and don't talk during this test. Okay? And if you feel uncomfortable or if you cannot tolerate the sound, please let me know. And do you have any question?
No.
Okay. Okay, I'm going to insert this probe tip into your ear canal. And I'm going to start. So I got 1.25 milliliter for ear canal volume, and then static compliance is 0.41 milliliter, and the peak pressure is minus 23 decapascal. So this tympanogram is type A, which shows normal middle ear function in the right ear. The next test I'm going to do is to check how well your middle ear muscle is working. There are tiny muscles in our middle ear space, and one of the muscle actually contracts when we hear loud sounds. And this test will show us how well your middle ear muscle is responding to loud sounds. So now you're gonna wear this headphone, and I'm going to insert this probe tip into your ear canal. Then you will hear a series of loud tones or noises. Each tone or noise will last for a second. You don't have to tell me that you hear the sounds. Please remain still and do not talk during this test. And if you feel uncomfortable with the noise, with the sounds, and if you cannot tolerate the sounds, please let me know. Do you have any questions?
No.
Okay. This is the headphone you're gonna wear. I'm going to put the probe. I'm going to insert this probe tip. Okay, start. Okay, this is the result of acoustic reflex test. And right ipsilateral acoustic reflex threshold for the 1000 hertz tone is 85, which is within normal limit. And right contralateral acoustic reflex threshold for the 1000 hertz tone is 90 or 95, which is within normal limit. And this is contralateral acoustic reflex thresholds for broadband noise. It's 75 decibel, which is within normal limit. Yeah, we talked about our middle ear muscle. The middle ear muscle will contract when we hear loud sounds. This time I'm going to check how well your middle ear muscle maintains its contraction when you hear a loud tone, like a loud constant tone. I'm going to insert this ear probe tip into your ear canal. Then you will hear a loud tone, and that's gonna last for 10 seconds. Okay. Please remain still, and you don't need to tell me when you don't have to tell me that you hear the tone. Just remain still and do not talk during this test. And if you feel uncomfortable with the sound, please let me know. Okay? I'm going to insert this probe tip into your ear. Okay. Then this ipsilateral acoustic reflex threshold that at 1000 was 85. So I'm going to go to acoustic reflex decay. Then I'm going to add 10 dB over the threshold. Okay, so which is 95. And I'm going to present the tone. Okay, it shows 14% decrease of reflex response over 10 seconds, so which is negative. So it's acoustic reflex decay is negative.